This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Here we go, solving another equation with fractions. Are you having fun yet? Okay, so when you have fractions in an equation, what you could do if you want to eliminate all the fractions is multiply both sides of the equation by the least common denominator. So let's see. The only denominators we have are 2 and 4. Hope you know that the least common denominator is 4. You're picking a number that both 2 and 4 go into. All right, so we have to multiply 4 by everything on both sides. By the way, most books do it like this. They put a parentheses around both and do a 4 on both sides. That's okay. Or put the 4 in front of here. Basically, you have to remember to multiply 4 to every term on both sides. Okay, so we have 4 times the 5 halves x plus 4 times the 1, 4 times that x. So you have to remember the right side too. Don't forget the right side. And 4 times 9/4. And then this is the fun part. We cancel, so we get an equation without fractions. All right, so let's see. 2 goes into 4 2 times. These are whole numbers, nothing's going to cancel there. And the 4 and 4 both go in. So what do I have left over here? We have 2 times 5. Don't forget to see both those numbers. 2 times 5 is 10x. It's all in the details in math. Plus 4 times 1 is 4. 4 times x, 4x. And 1 times 9 is 9. Yippee! An equation without fractions. Okay. So now we're going to subtract 4x from both sides because we want to get the variables on one side and constants on the other. May as well subtract 4 from both sides at the same time. So notice what I'm doing. I'm subtracting 4x minus 4, or I'm adding negative 4x minus 4 to both sides of the equation. And that gives me 6x equals 5. One more step, divide by 6. Now, notice you can always eliminate fractions to solve the equation, but you can't guarantee that your answer is not going to be a fraction, right? Okay, so 5/6 looks to be the solution unless I made a mistake. And of course, I'm not invincible. Most of us aren't, so you want to make sure that is the correct solution by checking it. So we want to check this in the original problem. You don't want to check it in this 10x plus 4 equals 4x plus 9 because maybe you made a mistake. You want to check it in the original equation. So let's do that. All right, so here's the original equation. We're going to plug in 5/6 for x. So we have 5 halves times 5/6, plugging in 5/6 for x, plus 1. Well, here we do order of operations. You multiply the numerators. That's 25/12 plus 1. Now, I know I'm going to have to get a common denominator in order to add. So I'm going to write 1 as 12/12 because that's the same thing as multiplying this 1 by 12 over 12. Convince yourself that 1 is the same thing as 12 divided by 12. Once you have a common denominator, you could add the numerators. So 25 plus 12 is 37/12. No reason to change that to a mixed number. It's a reduced improper fraction, perfectly fine. All right, now we need to plug in 5/6 for x on the other side of the equation. So we have 5/6. I'm going to leave a little space here, plus 9/4. Because I need to get a common denominator in order to add these fractions. You can't multiply that by 12 over 12. This is not an equation. We are simply plugging in something for x and seeing if both sides evaluate to the same number. So what's the least common denominator for 4 and 6? That would be 12. So we need to write both of those in terms of 12ths. Right? So how could I do that? I could multiply the 5/6 by 2 over 2 to get 12ths. And 9/4 I could do by 3 over 3. So that is 10/12 plus 27/12. So now that I have a common denominator, I can add the numerators. 10 plus 27 is 37. And you just write you don't add the denominators, right? Yay! It worked. Got the same number when I plugged in 5, 6. So 5, 6 is the correct solution. Yay! This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.